As the time-looping technology became more integrated into various sectors on Terra Nova, the first signs of unexpected anomalies began to emerge. These anomalies, subtle at first, gradually raised concerns among Dr. Iris Vaughn and her team, prompting a deeper investigation into the underlying causes. The initial clues appeared in the agricultural sector. Farmers and scientists at the Terra Nova Agricultural Research Institute noticed unusual patterns in the crops grown under accelerated cycles. While the plants were growing faster and yielding more, some displayed signs of genetic mutations that were not present in the original strains. These mutations included unexpected changes in color, size, and nutritional content, which puzzled the researchers. Dr. Li Cheng, the team's lead biologist, conducted a series of genetic analyses to understand the scope of these changes. What we're seeing here are not just minor variations, Li explained during a team meeting. Some of these mutations could affect the long-term viability and safety of these crops. We need to understand if these are isolated incidents or indicative of a broader issue. As the investigation deepened, the team discovered that the mutations were not limited to a single crop or location. Similar anomalies were reported in other experimental farms and even in controlled greenhouse environments. The mutations varied widely, suggesting that the time-looping process might be introducing or amplifying genetic variability in ways not yet understood. In parallel, the medical sector reported anomalies among patients undergoing time-looping treatments. While the technology had accelerated recovery rates and improved outcomes, a small number of patients began experiencing unusual side effects. These included memory lapses, altered perceptions of time, and in rare cases, unexplained physical symptoms such as localized numbness or tingling. Dr. Vaughn, deeply concerned by these reports, convened a multidisciplinary task force to investigate the anomalies. This group included geneticists, neurologists, and physicists, all tasked with examining the potential causes and implications of the observed changes. The goal was to determine whether the time loops themselves were a factor, and if so, to identify the mechanisms at play. The task force's initial findings pointed to a complex interplay of factors. In agriculture, the accelerated growth cycles appeared to be stressing the plants in ways that conventional growing methods did not. This stress, combined with the unique environmental conditions created by the time loops, seemed to be promoting genetic instability. In medicine, the anomalies among patients suggested that repeated exposure to time loops could be affecting neurological functions, possibly through mechanisms not yet fully understood. Public awareness of these issues grew as reports began to surface in the media. While the anomalies affected only a small percentage of cases, the potential implications were significant. There was concern about the safety and sustainability of time-looping technology, particularly given its expanding role in critical sectors like food production and healthcare. Dr. Vaughn addressed these concerns publicly, emphasizing the team's commitment to transparency and safety. "We are taking these findings very seriously," she stated in a press conference. "Our priority is to understand the root causes of these anomalies and to ensure that the technology is used responsibly. We are working closely with experts across multiple disciplines to conduct a thorough investigation." The anomalies also sparked renewed debate about the ethical dimensions of time-looping technology. Critics argued that the technology had been deployed too quickly without a full understanding of its potential risks. Supporters countered that the benefits still outweighed the drawbacks, but agreed that more rigorous safeguards and research were needed. In response, the Terra Nova government and TESA implemented additional oversight measures. All ongoing and future time-looping projects were required to include comprehensive risk assessments and enhanced monitoring protocols. The Oversight Committee also expanded its mandate to include a review of the anomalies and their potential long-term impacts. The chapter closed with the team redoubling their efforts to investigate the anomalies. They knew that their findings would be crucial not only for the future of time-looping technology on Terra Nova, but also for the broader global community looking to adopt similar innovations. The path ahead was fraught with uncertainty, but Dr. Vaughn and her team remained committed to navigating it with rigor, responsibility, and a deep commitment to the well-being of society and the environment. As the anomalies in the time-looping projects became more apparent, Dr. Iris Vaughn and her team intensified their investigative efforts. The urgency of understanding these anomalies was clear. The potential consequences for Terra Nova and the broader global community were significant. The team began by expanding their data collection and analysis. They installed advanced monitoring systems in all active time-looping sites, including agricultural fields, medical facilities, and research labs. These systems were designed to capture detailed information on environmental conditions, genetic changes, and patient health metrics, providing a comprehensive dataset for analysis. Dr. Li Cheng led the biological investigation, focusing on the genetic mutations observed in the crops. His team collected samples from various sites, including those showing significant mutations and others appearing normal. Using next-generation sequencing technologies, they sought to identify any commonalities or patterns that might explain the genetic instability. What we're seeing could be related to the stress of accelerated growth cycles, Li explained during a team meeting. It's possible that the rapid pace of development is pushing the plants beyond their natural adaptive capacities, leading to these genetic anomalies. We need to understand if this is a temporary response or something that could have longer-term implications for crop viability and safety. In the medical sector, Dr. Vaughn and the task force focused on patients reporting cognitive and neurological symptoms. They conducted in-depth clinical evaluations, including neuroimaging and cognitive testing, to assess the nature and extent of these effects. The results revealed a range of symptoms, from mild memory lapses to more severe disruptions in time perception and neurological function. Dr. Tomas Ibarra, a quantum physicist on the team, proposed a hypothesis that linked the anomalies to the fundamental properties of the time loops themselves. The repeated exposure to altered temporal states might be affecting neural processes in ways we're not fully aware of, he suggested. We need to explore the possibility that the time loops are not just accelerating physical recovery, but also impacting the brain's perception and processing of time. This hypothesis opened a new line of inquiry, prompting collaboration with external experts in quantum physics and neurobiology. The team sought to understand whether the anomalies were a result of direct physical changes induced by the time loops or whether they stemmed from more subtle, quantum-level interactions that affected biological systems in unpredictable ways. Public concern continued to grow as more details of the anomalies emerged. Dr. Vaughn and her team maintained open communication with the public, providing regular updates on their findings and the steps being taken to address the issues. They emphasized that while the anomalies were concerning, they were limited in scope and being carefully investigated. The Oversight Committee, recognizing the need for broader expert eyes, brought in additional specialists from around the globe to assist in the investigation. This included geneticists, neurologists, ethicists, and physicists who provided fresh perspectives and insights. The committee also launched an independent review of all time-looping projects, focusing on compliance with safety protocols and ethical standards. As the investigation progressed, Dr. Vaughn faced increasing pressure to pause all time-looping projects until the anomalies were fully understood. While some team members and stakeholders supported this cautious approach, others argued that halting the projects could disrupt critical services and research, particularly in agriculture and healthcare. Balancing these concerns, Dr. Vaughn advocated for a targeted pause on specific projects showing the most significant anomalies, while allowing others to continue under enhanced monitoring and safety measures. This approach aimed to minimize disruption while ensuring that the investigation could proceed without compromising public safety or confidence. The chapter concluded with the team working tirelessly to piece together the puzzle of the anomalies. They were acutely aware that their findings would have far-reaching implications, not only for the future of time-looping technology on Terra Nova, but also for the ethical and scientific frameworks governing its use globally. As they delved deeper into the complexities of their work, they remained committed to transparency, integrity, and the pursuit of knowledge for the greater good. The deeper Dr. Iris Vaughn and her team delved into the anomalies, the more complex and intertwined the issues became. The investigation revealed not just isolated incidents, but potential systemic effects related to the time-looping technology, raising critical questions about its broader implications and sustainability. In the agricultural sector, Dr. Li Cheng's team made significant progress in understanding the genetic mutations in crops. Their analyses pointed to a phenomenon known as genetic drift, accelerated by the repeated cycles of growth and harvesting under time-loop conditions. This drift led to increased genetic variability, which, while sometimes beneficial, often resulted in unforeseen and unstable traits. We're seeing that the time loops amplify natural genetic variations, creating new traits that may not have emerged under normal circumstances, Li explained in a research briefing. This could have significant implications for biodiversity and food security, especially if these traits are passed down through generations or if they cross-pollinate with natural plant populations. These findings prompted a broader ecological assessment, considering the potential long-term impacts on local ecosystems. The team collaborated with ecologists to study the effects of genetically altered crops on soil health, pollinators, and surrounding flora and fauna. The preliminary results indicated a risk of disrupting natural ecosystems, highlighting the need for stringent biosecurity measures and more controlled use of time looping in agriculture. In the medical domain, the investigation into patient symptoms uncovered another layer of complexity. Neuroimaging and cognitive assessments revealed subtle but pervasive changes in brain structure and function among patients exposed to prolonged time-loop treatments. These changes, while not immediately detrimental, suggested potential long-term effects on cognition and mental health. Dr. Tomas Ibarra and his colleagues explored the possibility that the anomalies were linked to quantum-level phenomena. They hypothesized that the manipulation of time within the loops could create temporal interference, subtly altering neural processes in ways not fully understood by conventional neuroscience. This theory, while still speculative, opened up new avenues of research into the intersection of quantum mechanics and biology. The team faced mounting ethical and practical dilemmas as they grappled with these findings. There was an urgent need to balance the potential benefits of the technology with the risks and uncertainties it introduced. The Oversight Committee, recognizing the gravity of the situation, called for an international summit to discuss the findings and develop a coordinated response. At the summit, experts from various fields, including ethics, law, and public health, gathered to evaluate the situation. They discussed the implications of the anomalies for public policy, research ethics, and global governance. The consensus was clear. While time-looping technology held transformative potential, its application required a much more cautious and measured approach than previously thought. Dr. Vaughn spoke at the summit, acknowledging the challenges and reaffirming her commitment to ethical stewardship. "We are navigating uncharted territory," she said. "The anomalies we have discovered are a reminder that with great innovation comes great responsibility. Our priority must be to safeguard public health and the environment, even as we explore the possibilities of this powerful technology." The summit resulted in several key recommendations: a temporary suspension of all non-essential time-looping projects, a moratorium on new applications until further research could clarify the risks, and the establishment of an independent global research body to oversee and coordinate investigations into the technology's effects. Back on Terra Nova, the team began to implement these recommendations, halting several projects and intensifying their research efforts. They also initiated a public information campaign to keep citizens informed about the situation and the steps being taken to address it. This transparency was crucial in maintaining public trust and ensuring that the community remained engaged in the ongoing dialogue about the technology's future. As the chapter drew to a close, Dr. Vaughn and her team faced a sobering reality. The promise of time-looping technology was undeniable, but so were its risks. The anomalies had exposed vulnerabilities in their understanding and application of the technology, highlighting the need for a more nuanced and responsible approach. Despite the challenges, there was also a sense of resolve. The team was committed to learning from the anomalies and using these lessons to refine their work. They recognized that the path forward would require patience, collaboration, and a deep respect for the complexities of the natural and human systems they were affecting. The journey of discovery and adaptation continued, with the team focused on ensuring that their innovations would ultimately contribute to a sustainable and ethical future for Terra Nova and beyond. The anomalies, while challenging, were also an opportunity to deepen their understanding and improve their practices, reinforcing the principle that true progress must always be guided by caution, humility, and a commitment to the common good. As the anomalies in the time-looping technology became more widely known, the ethical landscape surrounding its use grew increasingly complex. The initial enthusiasm for the technology's potential benefits was tempered by a more cautious and critical public discourse. Dr. Iris Vaughn and her team found themselves at the center of a global debate about the responsible development and deployment of advanced technologies. The International Summit had set the stage for a broader examination of the ethical implications of time looping. The creation of an independent global research body tasked with overseeing the technology's effects was a critical step toward ensuring that its use was carefully managed. This body, composed of experts from various fields, including ethics, law, science, and public health, began its work by establishing guidelines for ethical research and application. Dr. Vaughn and our team actively engaged with this new body, sharing their data and insights from the ongoing investigations. They were particularly focused on addressing the ethical concerns raised by the anomalies, including the potential long-term impacts on ecosystems, human health, and social equity. The team recognized that their work had implications far beyond the technical realm, touching on fundamental questions about the values and priorities of society. One of the primary ethical concerns was the issue of informed consent, particularly in the medical sector. The discovery of cognitive and neurological effects among patients who had undergone time-looping treatments raised serious questions about the adequacy of the informed consent process. Patients had agreed to the treatments based on an understanding of the benefits and risks as they were known at the time, but the emergence of new, previously unknown risks challenged the sufficiency of that consent. To address this, the team revised their protocols, introducing more comprehensive, informed consent processes. These included detailed explanations of the potential risks and uncertainties, as well as ongoing monitoring and support for patients experiencing side effects. The team also implemented regular reviews of patient data to ensure that new information was communicated promptly and transparently. In the agricultural sector, the ethical considerations centered on the environmental and economic impacts of the technology. The anomalies highlighted the potential for genetic drift and ecological disruption, raising concerns about biodiversity and the stability of food systems. There were also broader social justice issues, as the technology could potentially exacerbate inequalities between those who had access to the benefits of accelerated crop production and those who did not. To mitigate these risks, the team collaborated with environmental scientists, economists, and social scientists to develop strategies for sustainable and equitable use of time-looping technology in agriculture. This included stricter biosecurity measures to prevent the spread of genetically altered traits and policies to ensure that the benefits of increased food production were distributed fairly. Public engagement remained a crucial component of the team's approach. Dr. Vaughn and her colleagues participated in community forums, educational outreach programs, and media interviews, fostering an open dialogue with the public. They emphasized the importance of transparency and accountability, recognizing that public trust was essential for the continued exploration of the technology. The Oversight Committee, along with the newly established global research body, also played a key role in facilitating public discourse. They organized a series of international workshops and public hearings, inviting stakeholders from diverse backgrounds to discuss the ethical, social, and environmental dimensions of time-looping technology. These events provided a platform for voices that had been marginalized or overlooked, ensuring that a wide range of perspectives were considered in decision-making processes. As the ethical landscape continued to evolve, the team faced difficult choices about the future direction of their research. The temporary suspension of non-essential projects provided an opportunity to reflect on the lessons learned and to refine their strategies. Dr. Vaughn and her colleagues were determined to move forward in a way that prioritized ethical considerations and minimized risks. One of the key outcomes of this period was the development of a comprehensive ethical framework for time-looping technology. This framework, which was endorsed by the global research body, outlined principles and guidelines for the responsible use of the technology. It emphasized the need for ongoing assessment of risks and benefits, inclusive and transparent governance, and a commitment to social and environmental justice. The framework also called for international cooperation and coordination, recognizing that the challenges posed by time-looping technology were global in nature. It encouraged the sharing of data, best practices, and resources, and promoted the idea of collective stewardship of the technology. This approach aimed to ensure that the benefits of the technology were shared equitably and that its risks were managed in a way that protected the interests of all, particularly the most vulnerable. As the chapter concluded, Dr. Vaughn reflected on the journey so far. The ethical challenges they faced were daunting, but they also provided an opportunity to set a positive example for the responsible development of advanced technologies. The team was committed to navigating this complex landscape with integrity and a deep sense of responsibility. Looking ahead, they knew that the work of integrating time-looping technology into society was far from complete. The anomalies had exposed critical vulnerabilities and uncertainties, but they had also prompted a necessary and valuable re-examination of their practices and assumptions. Dr. Vaughn and her team were prepared to continue this journey, guided by the ethical principles they had established and a commitment to the well-being of all affected by their work. The ethical framework and international cooperation set the stage for a critical turning point in the development and application of time-looping technology. With the temporary suspension of non-essential projects in place, Dr. Iris Vaughn and her team focused on addressing the anomalies and refining their approach. This period was marked by intense research, collaboration, and a re-evaluation of the fundamental principles guiding their work. As the team continued to investigate the anomalies, they uncovered new insights into the mechanisms behind the observed genetic and neurological changes. In agriculture, further analysis revealed that the genetic mutations in crops were not merely random, but appeared to follow certain patterns, influenced by the specific environmental conditions created by the time loops. This finding suggested that with careful management might be possible to mitigate these effects, or even harness them for beneficial purposes, such as developing crops with enhanced resilience or nutritional value. Dr. Li Cheng's team experimented with adjusting the parameters of the time loops, such as the duration and frequency of the cycles, to see if they could reduce the incidence of undesirable mutations. They also explored integrating traditional farming practices with time-looping technology, aiming to strike a balance between innovation and sustainability. These efforts were part of a broader strategy to ensure that the technology could be used in a way that supported long-term ecological health and food security. In the medical field, the focus was on understanding and mitigating the cognitive and neurological side effects reported by some patients. The team, including neurologists and quantum physicists, hypothesized that these effects might be linked to subtle changes in neural circuitry caused by repeated exposure to altered temporal states. They developed a series of therapeutic protocols aimed at supporting patients' mental health and helping them adjust to their altered time perception. Dr. Vaughn and her colleagues also explored the potential for using time-looping technology in more controlled and targeted ways. For example, they considered limiting the use of time loops to specific stages of recovery or treatment rather than prolonged exposure, to minimize potential side effects. They also emphasized the importance of ongoing monitoring and patient support, recognizing that the long-term effects of the technology were still not fully understood. The team's efforts were supported by the newly established global research body, which provided additional resources and expertise. This collaboration facilitated the exchange of data and ideas, helping to advance the understanding of time-looping technology and its effects. The global body also played a crucial role in coordinating the development of international standards and best practices, ensuring a consistent and ethically grounded approach across different regions. Public engagement continued to be a priority. Dr. Vaughn and her team regularly communicated their findings and progress to the public, maintaining an open dialogue about the challenges and uncertainties they faced. They also sought feedback from diverse stakeholders, including patients, farmers, environmentalists, and community leaders, to ensure that their work was responsive to the needs and concerns of society. This period of reflection and refinement led to several key developments. First, the team proposed a phased resumption of time-looping projects, starting with pilot studies designed to test the new protocols and safety measures. These studies would be closely monitored and subject to strict oversight, with a focus on transparency and public accountability. Second, they advocated for a more integrated approach to research and development, emphasizing the need to consider the social, ethical, and environmental dimensions of their work alongside the scientific and technical aspects. This holistic perspective was seen as essential for ensuring that the technology could be developed and used in a way that was aligned with the values and priorities of society. Finally, there was a renewed emphasis on education and capacity building. The team worked with educators and policymakers to develop curricula and training programs aimed at building public understanding of time-looping technology and its implications. These programs were designed to empower individuals and communities to engage with the technology in an informed and critical way, fostering a culture of responsible innovation. As the chapter drew to a close, there was a sense of cautious optimism. The turning point represented by the anomalies and the subsequent response had been challenging, but it also provided an opportunity to chart a new course for the future. Dr. Vaughn and her team were committed to continuing their work with a renewed sense of purpose and a deeper understanding of the responsibilities they bore. The journey of integrating time-looping technology into society was ongoing, and there would undoubtedly be more challenges and uncertainties ahead. However, the lessons learned during this critical period had strengthened the team's resolve and provided a solid foundation for the road ahead. They were prepared to navigate this complex landscape with integrity, transparency, and a commitment to the common good, confident that they could help shape a future where technology served humanity in a positive and ethical way. Following the intense period of reflection and restructuring, Dr. Iris Vaughn and her team began to cautiously resume the time-looping projects, guided by the newly established ethical framework and global standards. This phase was characterized by a deliberate and measured approach aimed at rebuilding confidence in the technology while addressing the anomalies and potential risks that had been identified. The first projects to be restarted were carefully selected pilot studies, designed to test the revised protocols and safety measures. These studies were focused on areas where the benefits of time-looping technology were clear, but where previous applications had highlighted the need for more stringent controls and oversight. The emphasis was on transparency, with regular public updates and open access to data and findings. In the agricultural sector, the team implemented a new set of protocols that combined traditional farming practices with advanced technological controls. These included rotational crop cycles, organic soil enrichment, and the use of buffer zones to prevent the spread of genetically altered traits. The goal was to maintain ecological balance while exploring the potential benefits of accelerated growth cycles, such as increased yield and resilience to pests and climate change. Dr. Li Cheng and his colleagues conducted extensive monitoring of the pilot sites, focusing on genetic stability and ecological impacts. They also worked closely with local farmers and agricultural experts to ensure that the technology was adapted to local conditions and needs. This collaborative approach aimed to integrate the best of both traditional and modern practices, promoting sustainability and food security. In the medical field, the team introduced refined treatment protocols that limited the duration and intensity of exposure to time loops. These protocols were developed in consultation with neurologists, psychologists, and patient advocacy groups, ensuring a comprehensive understanding of the potential risks and benefits. The pilot studies were accompanied by robust patient support programs, including mental health services and regular follow-up assessments. Dr. Vaughn and her team were particularly attentive to the ethical dimensions of their work in healthcare. They implemented a new informed consent process that emphasized clear communication and patient autonomy, allowing individuals to make informed decisions about their participation in the studies. The team also established an independent ethics review board to oversee all medical applications of the technology, providing an additional layer of scrutiny and accountability. As these pilot projects progressed, the team faced ongoing challenges in balancing innovation with caution. They encountered unexpected variables and had to continuously adapt their approaches, guided by the principle of do no harm. This iterative process of trial and refinement was essential for ensuring that the technology could be safely integrated into society. Public engagement remained a key component of the team's strategy. They hosted regular community forums, educational workshops, and media briefings, fostering an open dialogue with the public. These efforts were aimed at demystifying the technology, addressing concerns, and building a shared understanding of its potential and limitations. The team also encouraged active participation in the decision-making process, inviting feedback and suggestions from a wide range of stakeholders. Internationally, the resumed projects were closely watched by other planets and societies interested in time-looping technology. The global research body facilitated the exchange of data and experiences, helping to establish a shared knowledge base and best practices. This collaborative network was crucial for addressing the complex challenges associated with the technology and ensuring that its development was guided by ethical and sustainable principles. The chapter highlighted several notable successes from the pilot studies. In agriculture, the integrated approach led to improved crop yields and reduced environmental impact, demonstrating the potential for time-looping technology to enhance food security without compromising ecological health. In healthcare, patients reported significant improvements in recovery times and quality of life, with the refined protocols minimizing the risk of cognitive and neurological side effects. These positive outcomes helped to restore confidence in the technology and reinforce the importance of the ethical framework that had been established. However, the team remained vigilant, aware that the technology's long-term effects were still not fully understood. They continued to advocate for ongoing research, public oversight, and a precautionary approach to further applications. Dr. Vaughn reflected on the progress made and the challenges ahead. The journey had been marked by setbacks and uncertainties, but it had also been a process of growth and learning. The team had developed a deeper appreciation for the complexities of their work and the importance of humility and responsibility in scientific innovation. As the chapter closed, there was a sense of renewed purpose and optimism. The lessons learned from the anomalies and the subsequent adjustments had strengthened the team's commitment to ethical stewardship. They were prepared to continue exploring the frontiers of time-looping technology, confident that they could contribute to a future where technology was used wisely and equitably for the benefit of all. The resumption of projects marked a new phase in the journey, one characterized by resilience, collaboration, and a steadfast dedication to the common good. Dr. Vaughn and her team looked forward to the continued evolution of their work, guided by a vision of a more just and sustainable world. As the pilot projects progressed, the successful integration of time-looping technology began to showcase its transformative potential. However, this success also brought Terra Nova to a critical crossroads: how to scale the technology responsibly while maintaining the rigorous ethical standards that had been established. This period was marked by both promise and caution, as stakeholders across the globe weighed the benefits against the potential risks. The agricultural pilot projects had demonstrated that time-looping technology could significantly enhance food production without compromising environmental health. The use of rotational crops, organic soil enrichment, and controlled time loops had resulted in increased yields and greater resilience to climate variability. These results sparked interest from international agricultural communities and policymakers eager to adopt similar practices to address food security challenges. However, the team, led by Dr. Iris Vaughn, emphasized that any expansion needed to be carefully managed. They advocated for a phased approach, starting with controlled environments and gradually moving to broader applications. This strategy was designed to monitor the long-term ecological impacts and ensure that the benefits were sustainable. Dr. Vaughn stressed the importance of sharing knowledge and best practices through international collaboration, helping other regions develop their capabilities while adhering to ethical guidelines. In healthcare, the refined protocols and patient support systems had significantly improved outcomes for those undergoing time loop treatments. Patients experienced faster recoveries and enhanced quality of life, with minimal adverse effects. These successes highlighted the potential for time-looping technology to revolutionize medical care, particularly in areas such as regenerative medicine and chronic disease management. The medical community, both on Terra Nova and internationally, expressed keen interest in expanding the use of time-looping technology. However, the team remained cautious, aware of the need to balance innovation with patient safety and ethical considerations. They proposed a global consortium of medical professionals, ethicists, and patient advocates to oversee the broader application of the technology, ensuring that it was used responsibly and equitably. The public response to these developments was mixed. Many were enthusiastic about the potential benefits of time-looping technology, seeing it as a tool for addressing pressing global challenges. Others remained concerned about the long-term risks and the possibility of unintended consequences. The team continued to engage with the public through forums, workshops, and media appearances, emphasizing transparency and inclusivity in the decision-making process. As discussions about the future of time-looping technology continued, new ethical dilemmas emerged. One significant concern was the potential for economic and social disparities. The technology's benefits were immense, but so were the costs of allotment, and implementation. There was a risk that wealthier regions or private entities could monopolize the technology, exacerbating existing inequalities. To address this, Dr. Vaughn and her team advocated for policies that promoted equitable access to time-looping technology. They proposed international agreements to ensure that the technology's benefits were distributed fairly, with special provisions for low-income regions. They also called for public funding and support to develop local capacities, enabling more equitable participation in the technological advancements. Another ethical consideration was the impact on labor markets and traditional industries. The automation and efficiency gains associated with time-looping technology could disrupt existing economic structures, leading to job displacement in sectors like agriculture and healthcare. The team collaborated with economists and social scientists to explore ways to mitigate these impacts, including retraining programs and strategies for integrating technology into traditional practices. As these debates unfolded, the Terra Nova government, in consultation with international partners, began to draft a comprehensive policy framework for the responsible expansion of time-looping technology. This framework aimed to balance innovation with ethical stewardship, prioritizing sustainability, equity, and public engagement. It included provisions for ongoing research, monitoring, and regulation, ensuring that the technology could evolve in a controlled and responsible manner. The global research body and the International Time-Looping Consortium played crucial roles in shaping this framework. They facilitated cross-border collaborations, shared data and best practices, and provided platforms for dialogue and consensus building. These efforts underscored the importance of a coordinated global response to the challenges and opportunities presented by time-looping technology. As the chapter neared its conclusion, it was clear that Terra Nova stood at a pivotal moment. The technology had proven its potential to bring about significant positive changes, but it also required careful management to avoid unintended negative consequences. Dr. Vaughn and her team remained committed to navigating this complex landscape with integrity, guided by the principles of ethical innovation and social responsibility. The crossroads of innovation presented both risks and opportunities. It was a moment that called for wisdom, foresight, and a collective commitment to the common good. Dr. Vaughn, reflecting on the journey so far, felt a deep sense of responsibility but also hope. The path forward was challenging, but it was also filled with the promise of building a more equitable and sustainable future. The team prepared to continue their work, mindful of the lessons learned and the need for ongoing vigilance and adaptation. They were ready to face the next phase of the journey, confident that with careful stewardship, time-looping technology could be a powerful force for positive change on Terra Nova and beyond. As Terra Nova and the international community moved towards broader integration of time-looping technology, the focus shifted to implementing the comprehensive policy framework developed by the Terra Novan government and its global partners. This framework, designed to ensure ethical and sustainable use, became a blueprint for countries and organizations looking to adopt the technology. However, as implementation began, the challenges of global integration and the complexities of managing such a powerful tool became increasingly apparent. One of the first major initiatives under the new framework was the establishment of the Global Time Looping Development Fund. This fund was created to support countries, particularly those with limited resources, in developing the infrastructure and expertise needed to implement time-looping technology. The fund also aimed to promote equitable access, ensuring that the benefits of the technology were not confined to wealthier nations or private enterprises. Dr. Iris Vaughn and her team played a pivotal role in the initial rollout of the fund, providing technical assistance and sharing best practices with partner nations. They conducted workshops, training sessions, and collaborative research projects to help local teams build their capacity. These efforts were critical in fostering a shared understanding of the technology's potential and risks, and in building a global network of practitioners committed to ethical standards. Despite these efforts, the integration process encountered significant hurdles. Cultural, economic, and regulatory differences between countries complicated the adoption of standardized practices. Some regions were more cautious, influenced by concerns about sovereignty and the potential for technology to disrupt traditional ways of life. Others were eager to embrace the technology, driven by pressing needs in agriculture, healthcare, and infrastructure. In agriculture, the challenge of managing genetically altered crops and ensuring ecological stability remained a top priority. While the new protocols had shown promise in pilot studies, scaling these practices to diverse environments proved complex. The team encountered variability in local climates, soil conditions, and biodiversity, which required adaptive management strategies. They worked closely with local experts to develop customized solutions, but the process highlighted the limitations of a one-size-fits-all approach. Healthcare applications faced their own set of challenges. While time-looping technology had the potential to revolutionize treatment and recovery, the infrastructure and expertise required were not uniformly available. In some regions, limited access to advanced medical facilities and trained personnel constrained the technology's effective deployment. Additionally, cultural differences in attitudes towards medical interventions and technology posed barriers to patient acceptance and participation. Public engagement and education emerged as critical components of the global integration effort. The team, along with international partners, launched a series of public awareness campaigns to inform citizens about the technology, its benefits, and potential risks. These campaigns aimed to demystify time-looping technology and foster informed public discourse. However, they also revealed varying levels of public trust and understanding, which influenced the pace and scope of adoption. The ethical landscape continued to evolve, with new dilemmas arising as the technology spread. One significant issue was the potential for socioeconomic inequalities to be exacerbated. There were concerns that regions or groups with greater access to the technology would gain disproportionate advantages, deepening existing disparities. The Global Time Looping Development Fund sought to address these issues, but the challenge of equitable distribution remained complex and multifaceted. Another emerging concern was the environmental impact of widespread adoption. While the technology offered solutions for enhancing food security and healthcare, its long-term effects on ecosystems and biodiversity were not fully understood. The team advocated for ongoing environmental monitoring and adaptive management to mitigate potential negative impacts, but there was recognition that some effects might only become apparent over time. In response to these challenges, the International Time Looping Consortium and the global research body intensified their efforts to coordinate research and policy development. They facilitated international conferences, joint research initiatives, and the sharing of data and best practices. These collaborations aim to build a more cohesive global response and ensure that the technology's development was guided by shared ethical principles. Dr. Vaughn, reflecting on the state of global integration, recognized the need for continued vigilance and adaptive management. The technology's potential was vast, but so were the responsibilities it entailed. She emphasized the importance of humility and the willingness to learn from both successes and setbacks. The path forward required not only technical expertise, but also a deep commitment to ethical stewardship and social responsibility. As the chapter concluded, the global community stood at a critical juncture. The integration of time-looping technology had made significant strides, but it also underscored the complexities and challenges of managing a powerful innovation on a global scale. Dr. Vaughn and her team, along with their international partners, were determined to continue their work, guided by the principles of transparency, equity, and sustainability. The journey of integrating time-looping technology into society was far from complete, and the road ahead was fraught with uncertainty. However, there was also a sense of hope and possibility. The global community had the opportunity to shape the future of this technology in a way that honored the values of justice, respect for diversity, and care for the environment. With these guiding principles, Dr. Vaughn and her team were prepared to face the challenges of the next phase, committed to building a future where technology served the common good and fostered a more equitable and sustainable world. As time-looping technology continued to be integrated into various sectors globally, unexpected consequences began to emerge. These unforeseen impacts, while initially subtle, grew in significance and complexity, prompting a new wave of challenges for Dr. Iris Vaughn and her team, as well as their international counterparts. The first signs of trouble surfaced in the agricultural sector, where the widespread adoption of genetically altered crops began to influence local ecosystems in unanticipated ways. Despite stringent biosecurity measures, instances of cross-pollination with native plant species were reported, leading to genetic contamination. This contamination threatened the integrity of local biodiversity and raised alarms among environmentalists and local communities. Dr. Li Cheng, who had been closely monitoring these developments, noted that the genetic traits introduced through time looping were spreading faster than expected. "We underestimated the mobility and adaptability of these traits," he explained. "The natural world is more interconnected than our controlled environments accounted for, and these changes are having cascading effects on local ecosystems." These effects included disruptions in local food webs, with some insect populations declining due to the altered plants, while others proliferated, causing further ecological imbalances. The situation called for an urgent reevaluation of the deployment strategies for genetically altered crops and reinforced the need for localized, adaptive management plans. In the healthcare sector, a different kind of unforeseen impact emerged. Patients who had undergone time-loop treatments for extended periods reported a range of new symptoms that were not previously documented. These included chronic fatigue, sleep disturbances, and a condition some described as temporal disorientation, where patients experienced difficulty in perceiving and relating to time in a normal manner. Dr. Vaughn and her medical team launched an in-depth investigation into these symptoms, collaborating with neurologists, psychologists, and quantum physicists. Their research suggested that prolonged exposure to altered temporal states might be affecting the brain's neural architecture, leading to changes in how time was processed and experienced. This revelation added a new layer of complexity to the ethical considerations surrounding the technology's use in medicine. The public reaction to these developments was one of growing concern and skepticism. While the initial adoption of time-looping technology had been met with enthusiasm, the emerging complications prompted a re-evaluation of its risks and benefits. Media outlets began to question whether the technology had been deployed too quickly without sufficient understanding of its long-term impacts. In response, Dr. Vaughn and her team intensified their efforts to communicate transparently with the public. They hosted town hall meetings, published detailed reports, and engaged with media representatives to provide a balanced perspective on the situation. They acknowledged the challenges and reiterated their commitment to addressing the issues responsibly and ethically. The international community, represented by the Global Time-Looping Consortium and the Global Research Body, also took action. They convened an emergency summit to discuss the unforeseen impacts and to develop a coordinated response. The summit highlighted the need for stronger international regulations, enhanced monitoring systems, and more robust frameworks for environmental and public health protection. A significant outcome of the summit was the decision to establish a global task force on time-looping impacts. This task force was charged with conducting a comprehensive review of all reported anomalies and developing a set of global guidelines for the technology's future use. It included experts from various fields, ensuring a multidisciplinary approach to understanding and mitigating the risks. The task force's initial findings confirmed that the impacts were not isolated incidents, but indicative of broader systemic issues. They recommended immediate measures, such as halting the expansion of time-looping applications until more data could be gathered and understood. They also called for an increase in funding for independent research to better understand the technology's long-term effects and to develop safer alternatives or modifications. Within Terra Nova, the situation prompted a re-evaluation of the technology's role in society. The government, in collaboration with TESA, launched a public inquiry to gather input from citizens, scientists, and industry stakeholders. This inquiry aimed to assess the societal, environmental, and ethical implications of time-looping technology and to determine the best path forward. Dr. Vaughn and her team, while facing increased scrutiny and pressure, remained committed to finding solutions. They focused on refining the technology, improving safety protocols, and enhancing support systems for those affected by its side effects. They also continued to advocate for a balanced and measured approach to innovation, emphasizing the need for caution and humility in the face of complex, interconnected challenges. The chapter closed with a sense of urgency and introspection. The unforeseen impacts of time-looping technology underscored the limits of human foresight and the importance of adaptive management. They highlighted the need for a global, collaborative effort to navigate the uncertainties and to ensure that technological progress did not come at an unacceptable cost to people and the planet. Dr. Vaughn, reflecting on the journey, recognized that the true measure of progress was not just in the advancements made, but in the ability to learn from mistakes and adapt to new realities. The team, and indeed the global community, faced a critical juncture where decisions made now would shape the future trajectory of time-looping technology and its role in society. They were committed to moving forward with integrity, guided by the lessons learned and a renewed commitment to the common good. In the wake of the unforeseen impacts of time-looping technology, the global community, led by Terra Nova, entered a phase of critical reassessment and redirection. The revelations about the technology's broader ecological and neurological effects, impeded a comprehensive review of its applications, policies, and future direction. The Global Task Force on Time-Looping Impacts, established during the emergency summit, completed its initial review. Their findings confirmed the widespread nature of the anomalies and underscored the urgent need for a cautious and responsible approach. The task force's report highlighted several key areas of concern: genetic contamination in agriculture, long-term health effects in patients, and the broader ecological and socioeconomic implications of the technology. In response, the task force recommended a temporary moratorium on the expansion of time-looping technology, allowing time for further research and the development of enhanced safety protocols. This moratorium was intended not as a permanent halt, but as a necessary pause to ensure that the technology's risks were fully understood and mitigated. The recommendations also included the establishment of an international research consortium to coordinate ongoing studies and share findings. Dr. Iris Vaughn and her team played a pivotal role in shaping these new policies. They actively participated in international discussions, sharing their data and experiences, and advocating for a balanced approach that considered both the technology's potential benefits and its risks. They emphasized the importance of a holistic understanding of time-looping technology, one that integrated scientific, ethical, and societal perspectives. The Terra Nova government, alongside the Global Time-Looping Consortium and other international bodies, endorsed the task force's recommendations. They announced the implementation of the moratorium, along with a renewed commitment to public transparency and engagement. This decision was met with mixed reactions. While many supported the cautious approach, others expressed concerns about the impact on economic and technological progress. Public forums and consultations were held to discuss the findings and the way forward. These events provided a platform for diverse voices, including scientists, ethicists, policymakers, environmentalists, and affected individuals. The dialogue was frank and sometimes contentious, reflecting the complexities and high stakes involved. However, it also underscored a shared commitment to finding a path that balanced innovation with ethical responsibility. One of the key outcomes of these discussions was a consensus on the need for more robust regulatory frameworks. These frameworks would include stricter controls on the use of time-looping technology, comprehensive monitoring systems, and mechanisms for rapid response to emerging risks. There was also a strong emphasis on the need for international cooperation and the sharing of best practices, recognizing that the challenges posed by the technology were global in nature. Dr. Vaughn and her team refocused their efforts on fundamental research, seeking to better understand the mechanisms behind the anomalies and to develop safer applications of the technology. They worked on refining the protocols for both agricultural and medical uses, exploring alternative methods and technologies that could complement or replace time looping in certain contexts. In agriculture, this involved studying the interactions between genetically altered crops and native species, with the aim of developing containment strategies to prevent cross-pollination. The team also explored the potential for using time looping in a more targeted and limited fashion, reducing the risk of widespread ecological impacts. They collaborated with environmental scientists and geneticists to develop guidelines for sustainable and responsible use. In healthcare, the focus was on understanding the long-term neurological effects of time-looping treatments. The team expanded their research to include more comprehensive neuroimaging and cognitive assessments, working with neurologists and psychologists to develop therapeutic protocols to mitigate any adverse effects. They also advocated for increased patient support and follow-up care, ensuring that those affected received the best possible treatment. As the global community adapted to the new reality, there was a growing recognition of the need for a broader conversation about the role of advanced technologies in society. The debate around time-looping technology highlighted fundamental questions about ethics, governance, and the balance between progress and caution. It underscored the importance of a societal approach to technological development, one that prioritized human and environmental well-being. The chapter closed with a sense of cautious optimism and a renewed commitment to ethical innovation. Dr. Vaughn, reflecting on the journey, saw the reassessment and redirection as necessary steps in the evolution of time-looping technology. The challenges they faced had revealed the limitations of current knowledge and the need for a more nuanced and thoughtful approach. The global community, guided by the lessons learned, was poised to continue exploring the potential of time-looping technology, but with a deeper awareness of its complexities and responsibilities. Dr. Vaughn and her team, along with their international partners, were dedicated to moving forward with integrity, guided by a vision of technology that served the common good and fostered a more just and sustainable world. The story of Terra Nova and time-looping technology was a microcosm of broader societal challenges: how to navigate the opportunities and risks of advanced technologies, how to govern them ethically and inclusively, and how to ensure that progress was truly beneficial for all. As they prepared for the next phase of their journey, Dr. Vaughn and her team were committed to building a future where innovation was guided by wisdom, humility, and a deep respect for life in all its forms.